All right, so let's do this next problem. So for this next problem, it says a husband and wife want to have 3 kids. What is the probability of the couple having 2 girls? All righty. So let's try to see if this is a binomial distribution. So for this one, do they tell us how many times are they going to repeat the experiment? And for this one, experiment is they're having a kid.
Yeah, so 3, right?
Cool. So they tell us they are repeating, how many times they're repeating the experiment, because they tell us they're having 3 kids. All right. So for this one, do we have a success and failure? Because in their eye, what would, like, based on the problem and how written, what would be considered a success if they have what?
2 girls.
Well, a success would be if they have a girl.
Okay.
So it will be a failure?
Boy.
Yeah, boy. Cool. So we have a clear division where we have success and we also have failure. All right. Let's see, what is the probability independent? So if they say they have a girl the first time, second time they have a baby, does it make it more likely they're going to have a girl, or is it still 50-50?
Still 50-50.
Still 50-50, so that's what we consider to be independent. So the probability will be 0.50, because it doesn't matter if they have a boy or a girl the first time. When they have their second kid, it's still going to be 50-50. All right, so that's why this is considered a binomial distribution, because we have a set amount of trial, we have a clear distinction between success and failure, and the probability is always independent. All right, so let's go ahead and do this one. So for this one, says, what is the probability of a couple having 2 girls? So we know n is equal to 3. I know p is equal to 0.50. What is x in this case scenario?
Is it 2?
Yeah, the 2. Perfect. All right. So for this one, do I have multiple outcomes, or do I only have a singular outcome that I'm looking for x? Well, if you look at it, since we only want x to be 2, pretty much we only want one outcome we're looking for. So this is a singular event. So what I'm going to do, I'm going to go ahead and use my calculator to figure this out. So let me switch over to calculator. All right, so first thing I want to go is second bars. Then you're going to go all the way down to binomial PDF. All right. So for this one, my trial is n, so n is equal to 3. If you look at p is going to be replaced by 0.5. And x, well, x is actually still 2, so we'll leave it as is, and we'll go to paste. So if we put enter, we get probability x is equal to 2 is equal to 0.375 or 37.5%. And that's it for that problem.
So it's 0.375?
Yeah, 0.375 or 37.5%.
Okay.
All right, so that's it for that first part. Any question for that first part? So for the second part is when we're going to introduce the binomial CDF. So all you kind of have to know is what the C stand for in CDF. So CDF, well, the C stand for is cumulative. So cumulative just means whatever that value is, anything equal to that value or below that value is going to actually find the probability for you. Kind of think about it when like your professor say, your final gonna be a cumulative test. Cumulative mean like whatever we learned from the beginning of class all the way to the last day of class. That's what the final is gonna cover. So when we talk
Have a
about
cumulative final. Just a question.
what was that?
Are we gonna have a cumulative final?
Well, like the final is gonna cover stuff that we have learned from the beginning, like population sample stuff like that, but nothing like relative that we just forgotten about. But yeah, it should be cumulative.
Okay.
So when we want to use the CDF, we want to use the CDF when we want to find a probability and a probability of an X value and all of the probability below it all the way down to 0. So that's when you want to use CDF. So let's go ahead and do this problem. So we already know n is equal to 3. We already know p is equal to 0.5. So we have to find what x is. So if you look at this problem, it says, what is the probability of the couple having less than 2 girls? So if you want them to have less than 2 girls, what are my possible x value?
Just one.
Is there other way to get less than 2 girls?
Zero.
Yeah, there you go. 0 and 1. So for this one, if you look at it, what we have to do, we have to find the probability x is equal to 0, and we're going to find the probability that x is equal to 1. So there's multiple ways that we could do this. You could actually find the probability that x is equal to 0, and then find the probability that x is equal to 1, and then add those two up. But what you do want to do, you kind of want to take advantage of the CDF. Because pretty much for the CDF, what you want to do, you want to tell it n is 3, p is 0.5, and then what you want to do, you want to get the highest of the x value, which is 1. And then what the binomial CDF will do, it will give you binomial, well, it will give you the probability that x is equal to 0. It will give you the probability that x is equal to 1. But what it'll do for you, it'll add those two up for you. So instead of you having to find the probability that x is equal to 0, x is equal to 1, and then adding those two up, the binomial distribution will do that for you. So that way you kind of want to know when to use the binomial CDF versus using binomial PDF. Any questions on why we're using CDF versus PDF in this case scenario? All right, so let me switch over to my calculator.
So you have to do them separately, right?
If you want to use PDF, yes.
Or what if you use CDF?
No, you do it all in one time.
So you press bars and then go down, or oh no, you go to math.
No, well, just follow along. So you want to hit the second button.
Uh-huh.
You go right here where it says VARS. You go all the way down to binomial CDF.
It just says X2 CDF. Oh
well,
no.
you pay attention and
Yeah.
you'll see what I'm doing. So you go trial is 3. You go P is 0.50. And then you go X, which X is equal to 1. So if you do binomial CDF, it's going to give you the probability when X is equal to 1, but anything below that, all the way to 0. So if you hit paste, press enter, it'll give you 0.5 or 50%.
So go back. Can we go back to the papers? So we go. So the total of everything is 50?
Correct.
Even if
Yeah.
it's probability of 0 plus the probability of 1.
Yeah,
Is-
well, because if you look right now, I'm gonna do it individually. So if you find the probability of 1, it's 0.375. If you find the probability of 0, is 0.125. So if you do 0.375 plus 0.125, that's actually 0.50, which we got by doing CDF.
So, okay.
All right.
So CDF for multiple outcomes, PDF for single outcomes.
Correct. So, but also just remember, Alan, for CDF is when you want to get that value all the way down to 0.
Yeah, it's only 0 to the value.
Yeah, because if I wanted to say do like 6 to 10, you will have to do a different. You could still use CDF, but it will be slightly a little bit different because you do have to use the complement rule, because that's what the next problem is going to kind of show.
Sure.
All right. But any question in regard to this last problem? All right then. So let's go back to the iPad. Let me connect. All right, so let's go ahead and do this problem. So this is a quiz for a psychology class consists of 10 questions. The questions are multiple choice with 5 possible answers, each with only one correct answer. If the student did not study and guessing for all 10 questions. So let's go ahead and kind of like dissect this problem and see why is it binomial. So for this one, how many total questions do we have?
10.
10. So that means n is equal to 10. All right. So let's go ahead and see if there's a success and failure. So for this one, what would be considered a success? Did they get the question correct or did they get the question incorrect?
Correct answer?
Yeah, perfect. Thanks, Anthony. So a success will be considered if they get the correct answer, and a failure will be considered if they get it wrong. So we have a clear division of success and failure. What about the probability? What's the probability that they get the question correct? Like how many choices do they have to choose from?
5.
Cool, thanks, Amanda. So you get 1 out of 5. Because if you have 5 choices, there's only one correct answer. So if there's only one correct answer out of the 5, it will be 1 out of 5. And for this one, since we're assuming the student did not study and gets guessing, it doesn't really matter if they get the first question correct, because if they're going to guess on the second question, the third question, the fourth question, all the way to the 10th question, pretty much we could assume that for each one, they have a 1 in 5 chance of getting it correct. Any question in regard to how we got P?
So that's the answer.
Well, for right now, that's pretty much how we know the binomial distribution. We still haven't done part A.
Oh, okay.
So if you look at part A said, what are the probability of that student getting one correct answer? So how many correct answers do we want that one student to get?
1.
1. So for this one, would I be using PDF or should I be using CDF? Cool, thanks, Caesar. So yeah, so you want to use PDF for this one? Because if you look at it, they're telling us we only want to find the probability when x is equal to exactly 1. So since we want to find the probability when x is equal to exactly 1, You do want to use PDF because we only want that one probability. We don't want multiple probability. So let's go over. So in our calculator, N, you're going to put 10. P, you're going to put 1 out of 5 or 0.20. And for X, you're going to put 1 and make sure that you use the PDF. So let me switch it over to my calculator. So you want to go second. You want to go VARS. We go right here where it says binomial PDF. If you look at trial, trial will be 10. If you look at P, P will be equal to 1 divided by 5. You don't want to convert that to a decimal. And X, X will equal to 1. So we go to paste, we go to answer. So we get probability X is equal to 1 is equal to 0.2684. And that will be equal to part A. So let me switch it over to my iPad for you to see how I wrote out the answer. So that's part A. Any question in regard to how I got part A? All right. So let's do part B. So part B, I'm going to warn you, it is going to be a little bit different because for this one, you do have to use the CDF, but you're also going to want to use the complement rule because pretty much the calculator won't give us exactly this probability. You're going to have to use the complement rule to be able to find this probability. So that's your warning for part B. So for part B, it says, what is the probability of that student getting a passing grade? So we have to figure out what's considered a passing grade. So if you look at a passing grade, it's considered a 70%. So 70% correct is passing. So if there's 10 questions, what's 70% of 10 questions? So how many questions do I have to get right in order for me to get a 70% for this quiz?
7 questions.
Yeah, 7. Thanks, Anthony. Thanks, Christian, too. All right. All right. But is that the only way I could get a passing grade? Because say if I get like 80%,
Like
would
8,
that be still
9, and
considered-
10.
Yeah. So we want 8, 9, and 10. So thanks, Caesar. So you get 7, 8, 9, and 10 because those are the different ways that you could get a passing grade. Because if you get 7 out of 10, 8 out of 10, 9 out of 10, or 10 out of 10, that's literally considered passing. All right. So if you kind of notice for this one, you could take the route where we could find the probability that X is equal to 7, X is equal to 8, X is equal to 9, X is equal to 10, and then add those up. And that's one way you could get the probability. So that's pretty much the long way. Any questions so far on how we got the X? All right. So one thing you have to kind of realize, for this one, I can't really use the CDF to get the direct answer, but I can use it to get the indirect answer. Because one thing you have to remember for CDF, whatever number you say, so if I say X is equal to 5, for a CDF, if I put X is equal to 5, what the CDF will do will give me the probability of 0, 1, 2, 3, 4, and 5. So it'll give me that biggest number all the way down to 0. But if you kind of look at it, we want to go 7, 8, 9, and 10. So what we're going to do, we're going to find the probability of not passing. So we're going to find the probability of not passing, because if I get the probability of not passing and do 1 minus that, that should give me the probability of passing.
That's a
So
compliment.
that's the complement, exactly. So if I want to find the probability of not passing, what score should I get on this quiz? 0 all the way to what?
6.
Perfect. Competition. 4, 5, 6. And if you look at this, this is something CDF will actually give me, because if I put, if I do binomial CDF, if I say N is 10, P is 1 out of 5, for this one, what should I put for my X value? Because if I look at all of these X value, which is the biggest X value I have here? Cool, 6. Thanks, Amanda. So you put 6 right there. So what I'm going to do, I'm going to find binomial CDF when X is equal to 6. And this will give me the probability of not passing. But I don't want that probability. I'm going to actually take the complement of that. And that should give me the answer. So right now what I'm going to do, I'm going to transition over to my calculator for that way you can see
I have
how
a
I
question.
answer. Yeah, what's up?
Where did the 1 out of 5 come from?
So the 1 out of 5, where did that come from? Because there are 5 options for each multiple choice question, and only one of them is correct. So that's where the 1 out of 5 come from.
Oh, okay.
So what I'm gonna do, I'm gonna hit second, bars. We're gonna do binomial CDF. 10 will be my trial. P will be 1 out of 5. And X will be equal to 6. So that gives me 0.9991. So if I want to find the probability of not passing, well, if I want to find the probability of not passing, this is the probability of not passing. But the thing is, I want to find the probability of passing. So we have to do 1 minus, and I say 0.9991. So if you look at it, it gave me 9e to the negative 4. So just remember that's scientific notation. So telling me to get that decimal, which is behind the 9, and move it 4 bases to the left. So that means we're going to get 0.0009. And let me switch it over to my calculator for that we could see, oh, sorry, to my notepad.
That I burned the eggs.
So if you look at it, the way I wrote it, I wrote X is greater than or equal to 7 because we want it to be 7 to be the lowest number, but it could be 8, 9, and 10. So that way I say greater than or equal to 7, but you don't really have to worry about that. And then you say 9e to the negative 4, which is equal to 0.0009. So kind of telling us is very unlikely if somebody didn't study for a quiz or for this quiz, it's very unlikely for them to get a passing grade.
So why not do 1 minus answer?
Oh, you can also do that. Yeah, can you do second? So you did 1 minus second the answer, or second the negative. Yeah, you could do that.
I have a question.
Yeah.
Can you write it out as probability? Like I put like P of like X equals like passing. Is that okay or no?
Yeah, that's fine.
Okay.
All right. Any question in regard to this problem? All right, so let's scroll on down. So up next, we're gonna go over for a binomial distribution. There's a way to find the mean and there's a way to find the standard deviation. So if you see the circle or black dot, that you mean multiplication. So if I want to find the mean, all you have to do is get n multiplied by p. If I want to find standard deviation, you have to take the square root of n times p times q. Everybody good with that? And just remember the mean is exactly the same thing as the average or the expected value. It's telling us how many correct or how many success we should be expecting to occur. The standard deviation is telling us, okay, we're not always gonna get that many success, but this is how much it should deviate from that. So let's go ahead and do this first problem. So it says a quiz for psychology class consists of 10 questions. The questions are multiple choice with 4 possible answers each. A student is randomly selected. A student randomly guesses on 10 questions. So first thing we're going to do is figure out what is n. So for this one, what would be n?
10.
Yeah, 10. All right. What would be p?
4.
Well, 1 out of 4.
Uh-oh.
What would be q for this case scenario? Yeah, 3 out of 4. Perfect. So yeah, so you do want to be able to get out of that. So n in this case is equal to 10. P is equal to 1 out of 4 because there's one correct answer out of the 4 options. And Q will be 3 out of 4 because there's 3 wrong answers out of the 4 possible answer. All right, so let's do A. So A says find the mean and write a sentence describing what does it represent. So let's do that. So we have the mean, which is equal to n multiplied by p, which is equal to 10 times 1 out of 4.
Why are we doing in a sample instead of population?
So for this one, since we're doing, pretty much we're doing the population for this one problem. So since there's only 10 questions, this one should always be considered out of a population.
Okay.
Okay. So if you do 10 times 1 over 4, that should give you 2.5. So for this one, Tanya, if a person is guessing, so for this one, we'll say if a person is guessing on the quiz, we should expect them to get 2 to 3 correct. Because if you look at it, we got 2.5, but it's kind of not possible for a multiple choice quiz for you to get 2.5 correct. So you're telling us we should expect them to get anywhere from 2 to 3 correct on this quiz. And that's it for A. Any question in regard to A? So let's do B. So B says find the standard deviation and write a sentence describing what it represents. All right. So for standard deviation, we're going to say square root of n times P times Q. So that means we're going to do square root what is that? 10 times 1 over 4 times 3 over 4. So it's a square root of 10 times 1 divided by 4 times 3 divided by 4. And we should get 1.37. Any question? I got the 1.37. All right. So the standard deviation to tell you how so for the standard deviation is the average distance each quiz score should be from the mean if a student is guessing. So it's telling us not all students are going to get roughly 2 to 3 questions. Some of them might get 4 questions correct, or some of them might get 1 question correct, or 0 question correct. So the standard deviation is telling us how far away from the mean we could get before it starts getting suspicious. So if you kind of look at it, with the standard deviation and with the mean, it's kind of telling us somebody should score anywhere from 1 to 4 questions correct. So if somebody absolutely gets guessing and they guess correct like 9 out of the 10 questions, we kind of know that's a little bit suspicious because you're going like, if they're just guessing, you shouldn't be able to guess 9 out of the 10 questions correct. So that's what the standard deviation is. Any question in regard to standard deviation or how to find standard deviation? All right, so let's scroll on down. All right. So let's do these next two. I think my screen froze. Let me stop share. And let's share.